Right. Okay, now it's fine, right? Okay, now it's fine, right? Okay. Right, we'll start. Good evening again. Right, sorry for the delay. The thing is, I don't know whether it's something wrong with my YouTube account. Now, this happens for the second time today. When I put on a live on YouTube, two duplicates lives are created. Right? In last Thursday also, the theory which they know, same thing happened. Right? When I stream on YouTube, same live is duplicated. If one is deleted, both gets deleted, right? So today also the same thing happened, right? And now today one live is automatically ended, right? That's why I had to check again, right? I think it's fine now. I'll check whether whether it's something with my end, right? So first day I thought it's a bug or glitch or something from YouTube, but today again it happened for the second time. Okay, right, we'll start. Okay, listen. Listen. So first thing is, this week I have to close all the submissions by, last week. Last week I had to close all the submissions by the midnight of Friday because you wrote an essay paper, right? It was a full essay paper, consists of 4 structured essays and 4 essays, right? So usually to mark such a paper, it takes around 30 to 40 minutes of time, right? So that's why I had to close the submissions by Friday night, by Friday midnight, right? Otherwise, if it was a MCQ, in last week also I allowed you to submit on the Saturday as well, but this time I had to do that way because otherwise I'll be running out to mark papers, right? Now even today also, I didn't get any time to upload your marking sheets, for the online ones, to upload your answer sheets yet, right? So I'll do it during the class if I get time. If not, I will upload it after the class. And I didn't get the rank list yet, right? Because what actually happened was, the main one who is doing marking was kind of busy this week due to some other thing, right? So therefore, that's why it happened, right? I will get the list in the class, during the class. So once I get the rank list, I will give you the ranks. And for the online ones, for the physical ones, I gave you the mark papers, right? For late submissions, I will consider during the week, right? It won't be in the rank list now since it was late. And we'll get the rank list during the class. Once I get the rank list, we'll give you the rank list, right? So until I get the rank list, we'll go to the discussion, right? All right. Let's see. What? By 4. Marks are given out of 200, right? Marks are given out of 200, right? This was a full paper you wrote, right? Listen. I will update the marks accordingly for the online ones. For the physical ones, if you need to do the sum, the final mark is given out of 200, right? Why? What's the reason? You wrote 4 structured essays. You wrote 4 structured essays. One structured essay is 20 marks, right? So here you have 80 marks. Now this is a full paper, right? Here onwards, you will be having full papers only, right? And 4 essays. One essay carries 4 essays. One essay carries 30 marks. 30 into 4, right? 120. So that is 200 altogether. Final mark is given out of 200, right? To get the final mark, right, what you can do is divide this by 4, right? Now as an example, if you have got say 180, right? 180 means you have got 45 marks out of 50, something like that, right? So if there is say 120, right, then 30 marks out of 50, something like that, and add it with the part 1, right? This thing over 4 plus the final mark of part 1 is the final grade for the paper, right? Okay, so just wait until I get the rank list, right? Until we are getting the rank list, we will start the discussion. Once I get the rank list, I will give you the ranks. So that's the exact reason I had to close the submissions by Friday, right? Then සමහර අය 3යි ඔතනත් ඔන්ලයින් එකෙත් මම හිතන්නේ දෙන්නෙක් තුන් දෙනෙක් නෑ එහෙම නැතුවත් මාක් කරගන්න අමාරු නා. Right, let's see. Now it's working fine, right? Right. Right, let's see. Question 1. Go to question 1. Question 1. Right, go to question 1. It says, and before that, how was the paper? Online? How was it? How was the paper? This is the first paper you wrote as I mean four structured essays and 4 essays, right? And in all other ones, second parts consists only of 2 structured essays and 2 essays. How was it? Until it's graded. Other than that. Right. Online. What about you? Raise your hand. Online students, huh? Raise your hand if the paper is hard. Online. Raise your hand if this paper is hard. And I put a sonometer question as well because we discussed in the practical seminar, right? One sonometer question. So no one raises hand, which means it is easy. Is it? Okay, then raise your hand if the paper is average. Average. Online? All right, we'll start. Question 1. A metal sheet with a circular hole of radius d. It is not radius actually, it is diameter. Now when it is marked, since d is marked in the diagram, I considered it as a diameter, right? Right, even though it's given as radius, it is marked and it is given as d. Radius d, right? So therefore, assuming that you all have that common sense, I considered it as a diameter, right? ඒක diameter එක කියලා අරගෙන තමයි mark කරේ, right? Radius, if the radius is given, it should be given as r. That is one thing. And in the diagram given, d is marked, so it should be the diameter. Okay. The length AB and D are of the order of few centimeters. T less than 10 centimeters. The thickness of the sheet is of the order of few millimeters. What is the most suitable measuring instrument to measure the thickness of the metal sheet? That is few millimeters, it says. Question 1, part 1. Question 1, part 1. Question 1, part 1. It says thickness is few millimeters, no? Then what is the suitable one to measure the thickness? Micrometer screw gauge, right? So when measuring something like a metal sheet, we are actually more towards the micrometer screw gauge. The other reason is that is the only instrument you can get an indication about the proper tightness. Otherwise, if you are going to use something like a spirometer or maybe a vernier caliper, we don't have any idea or any indication about how properly it is tight between those two. No? In a micrometer screw gauge, we have a proper mechanism. So which means without damaging the sheet, without damaging the thickness of the sheet, you can stop rotating the thimble when ticking sound is coming from the thimble head. Right? So therefore, always keep that in mind when you measure something like metal sheets, metal wires, right? We are always more towards micrometer screw gauge, right? So the first one, micrometer screw gauge. Micrometer screw gauge. Second one. What is the important experimental step that should be carried out before using the above instrument? What is it? It's A and B. A and B. What's it? Huh? Checking zero error, right? Checking zero error, that's it. Right? You no need to explain. Don't need to explain, no? Just write down checking zero error, that's it. Experimental step. Checking zero error. Right? So no need to explain how zero error is measured here. Always for structured questions, you have to write concise answers. Right? Concise I have explained. Concise means to the point, and it should be like short and sweet language. Short and sweet answers, concise answers. Right? Should be to the point. Right? See, the above measurements were taken using a vernier caliper. State which parts of vernier caliper should be used to measure each of the following dimensions. A is a length, no? What can be used? External jaws, right? External jaws. External jaws. B is also external jaws. That's also a length. Width, no? External jaws. D is an internal diameter of a hole. That's a hole, right? Then you have to put internal jaws into the hole and get the internal diameter. That's an internal diameter. For that, internal jaws. Right? D. What is the most suitable laboratory instrument to measure the mass of metal sheet? Right? First check whether is there any hint given about the mass. Nothing is given, no? Nothing is given. Then the question is open. You have to focus on accuracy and give an answer. What's the most suitable instrument? It says a thin metal sheet, right? No, it doesn't say thin, but it says thickness is few millimeters, right? Thin ki vachana use karana, the word thin is not used, but we know that is few millimeters. And lengths are also less than 10 centimeters. That's a small sheet. Okay, what's the best one? Tell me. Electronic balance. Good. What else? Electronic balance is correct. Electronic balance. What else? Or else 4-beam balance, not the triple beam, 4-beam. Electronic balance or 4-beam balance. 4-beam balance or chemical balance. Chemical balance. Chemical balance. Right? So if you have written any out of these three, it is correct. E. Using the above measurements and standard formula, write an expression for the density of metal. Right. Mass is given as simple m in the above one. Density. Density is asked. To write density, first hand you need volume. Right. Mass is m, no, it's given. Then you need volume. How to write the volume here? Right. See, now if anyone can write this at once, totally fine. Right. I'm just writing the volume separately for you to understand. Volume can be written as cross-sectional area into thickness. No, volume is cross-sectional area into thickness. Cross-sectional area of the sheet is total area is A times B, right? Minus the whole. Whole is a circle, pi r squared. Then phi radius is d over 2 squared, right? This whole thing into this is the area into thickness. Thickness is given as T, right? Thickness is T. This is the volume. If volume is known, density is rho equals m over v, no? Right? So density is m over v. V is here. V is here. AB minus pi d squared dou 4 times T. Final answer. F. Measurements obtained at several places for the thickness of metal sheets are given below. 3.50, 3.51, 3.52, 3.51, 3.53. What is the least count of the measuring instrument? What's the logic behind least count? If readings are given, readings are taken, no, readings can be taken only up to the least count of the instrument, right? Now you can see 2 decimals are taken and consider the second decimal. 0 is there, 1 is there, 2 is there, 3 is there. So which means all decimals are also there. To take all decimals up to the second decimal, least count should be 0.01, right? If given readings were, listen, something additional. If given readings were, say, only the multipliers of 0.2, like 3.50 and 3.52, sorry, 3.502. No, 50 नहीं दिला देखे मैंने मैं वगैरह बनाना like 3.50, 3.52, 3.54. Now in such a case, least count is not 0.01, right? That is 0.02. Now in this case, since all values from 0, 1, 2, 3 are taken, then least count should be 0.01, right? Otherwise such cases are also there because we have least counts with 0.02, 0.2. Then only even numbers, even decimals can be there. That you have to check. Right now in this particular case, there is 0.01. F1 0.01 millimeters. Second one, calculate the mean thickness of the sheet. Mean average at these values and divide by 5. Mean thickness. Simple. Mean, very simple. 3.50 plus 3.51 plus 3.52 plus 3.51 plus 3.53 over 5. What's the value? Is it 3.42? No, it's wrong. What's the value? A simple part, just the average. And 3.53. 3.514, is it? 3.514, right? 3.514 millimeters, right? So even if you write 3.51, that is also fine. Even if you write 3.51 millimeters, right, this is also fine. Number 3. Number 3. How many decimal places can be included in your answer? It is asked because you have got 3 decimal places here, right? Otherwise, there's no point of asking that question, no? That is why that particular question is asked. How many decimal places can be included in your answer? Explain the reason for your answer. How many decimal places? Only 2. Only 2 because least count of my instrument is only up to 2 decimals. Right? Then only 2. Only 2. Explain the reason. Right? Write the reason. Least count of instrument. Least count of instrument is only up to 2 decimal millimeters. Least count of the instrument is only up to 2 decimal millimeters. Least count of the instrument is only up to 2 decimal millimeters. Least count of instrument is only up to 2 decimal millimeters. Right. Take it down. Right. Any questions? Either. I got 3.515 millimeters, so I wrote 3.52. No, it should be 3.514, right? Should be 3.514 only, right? Simplify these 5 and see. Are 514 in it? Right? So 515 gonna be. So you can't write 515 there and 3.52 millimeters. Then is it correct? No. Can you explain part T again? What is part T? Part T. Here. Volume. Volume. Right? First idea is volume can be written as area times thickness. Right? Area into thickness is volume, no? Right? Area into thickness is volume. Then if you have this kind of a sheet, right? Say you got you had this type of a sheet, something like this type of a sheet, right? If this area is, let's say, AB, if this area is AB and this thickness is T, cross-sectional area is AB. AB into length, height, or depth, anything, right? Can be written as volume. A simple idea, cross-sectional area into depth. Now, there was a hole inside. Then from this area, subtract the hole. from this area, subtract the whole. Whole is a cylinder. Sorry, whole is a circle. I mean, in terms of area and into this whole area into cross-sectional into depth gives you the volume. Or else another way that you can do the same is, right, if you didn't understand that way, you can consider this whole thing as a cuboid. From that cuboid, subtract this cylinder. This is a cuboid, no? From this cuboid, subtract the cylindrical part. But this is easier. Cross-sectional area times depth times thickness. Cross-sectional area from total area, subtract the whole. Right? 17. Right. Any questions about question 1? Let's move on. Next one. Question 2. See? Question 2. So we discussed the sonometer recently in the practical seminar. Right? We discussed the sonometer recently in the practical seminar. But this is not the exact one we have in the guide. Right? This is a modified one. Right? Maybe a modified there. Right? This is a modified one. Changes can make a key. We'll see. Right. Question 2. Question 2. A laboratory set up to investigate the variation of vibrating frequency F of a stretched string with the tension T in the string using sonometer is shown in the figure. You are provided with a meter ruler, a tuning fork of known frequency, a set of weights from 100 grams to 500 grams, and paper riders. Sonometer wire A is under certain tension. Wire B is passed over smooth pulley with a scale pan attached to its end. Wire B, right. Attached to the end. The tension of wire B can be varied by adding weights to the scale pan. Right. Part A. Write an expression for the fundamental frequency F of wire B in terms of T, tension of the wire, L, vibrating length, and M, mass per unit length. Right. So we know wire B is going to vibrate in between these two paper riders. It is going to vibrate in between these two paper riders. So first pattern is, so the fundamental pattern is this. And this length is given as L. Right? Very simple. One loop is lambda over 2 over lambda over 4. One loop is lambda over 2. Right? 2. Lambda over 2. One loop is lambda over 2 equals L. Then lambda is known. Lambda equals 2L. Right? And we need frequency. Then apply. These are wire, no? Transverse waves through wires, V equals root T over M. But we know V equals F lambda. Right? Then F lambda is 2L equals, in terms of T and M, no? Root T over M. You need F. Just subject this. 1 over 2L root T over M. This is what is expected. Right? So if you have used less number of lines compared to this, that is totally fine. Right? I'm writing all these lines to anyone in any level to understand. Right? Otherwise, if you can simplify faster, that is totally fine. And that is a skill you have got, no? That's a skill. Simplification is a skill. B. Taking t as the independent variable. That's a difference now. Right? If you can remember the general experiment we have, right? There t is not a variable in that general one. What is being varied?